In this video, we're going to take a look at how we determine different characteristics of a quadratic function in standard form. So we are going to take a look at these 5 key characteristics here. So we will determine from an equation if a graph opens up or down. So that would be opening up or opening down. We will be able to find the y-intercept. So if we're looking at a graph, remember the y-intercept is going to be the point where it crosses the y-axis. We will also be able to tell if the vertex is located to the right or the left or on the y-axis. We will also be able to find the vertex. So remember, the vertex of a parabola is going to be either that lowest point or that highest point, depending on which way it opens. And then we will be able to find the x-intercepts, which again, the x-intercepts, just like the y-intercept, is going to be where it crosses this time the x-axis. So those are the key characteristics we are going to look for. Before we get into key characteristics, just a quick review of what standard form is. So remember, in a quadratic equation, we want to see that highest exponent of 2 in standard form on any of the x's in order to make it a quadratic equation. Now, a, b, and c will actually be our numbers in those places, and they won't be a, b, and c in the actual equation. So I give you some examples down here. Sometimes all 3 terms are present. Sometimes it's just 2 terms. For example, this one down here only has an x squared term, which is this ax squared, and a minus 8, which is the constant here. So that last one down there does not have a b value. In other words, the b value is 0. So just a quick note, you would definitely want to be able to determine what a, b, and c are. So for example, here in this first one, a is 3, b is -5, and c is 7. Looking at that second example, a is -2, b is 7, and c is 4. Looking at this third example, a is 5, b is +8, and c is -9. So it's always the coefficient on the x or the x squared, or if it's a constant, then it's just the constant itself, including the sign in front of that coefficient or constant always. Now this one is a little trickier because there is no number in front of the x squared, so that's really a 1. So on this one, a is going to be 1, and then b is -3, and c is -5. And then on this bottom one, a is 6, because that's what's in front of x squared. Remember, there is no b term, there is no just simple x term. And so with that, that means b is 0. And then our constant is c, which is -8. Now, to determine if the graph opens up or down, in that standard form equation, ax squared plus bx plus c equal to y or equal to f of x, that a is going to tell us what our parabola does, if it opens up or if it opens down. So if a is positive, then the parabola opens up. In other words, the arrows are pointing up. If a is negative, then the parabola opens down, and so that would look something like this. So you can see in these 2 examples here, I give you this one, a is 1, which is positive. Over here, a is -1, which is negative. So when it was +1 for a, it opened up. When it was -1 for a, it opened down. Now to find the y-intercept, so remember the y-intercept is the place where the graph crosses the y-axis. So that is going to be found by plugging in 0 for x and evaluating to solve for y. And then we'll do that on the first one, and we'll talk about what the pattern is there. So when we plug in 0 for x, it's 0 squared plus 6 times 0 minus 7. So that's going to be 0 squared is 0. 6 times 0 is 0, and then we just have -7. So -7 is what we get when we do 0 plus 0 minus 7. So the y value is -7. You will see that that is the c value in standard form. So this -7 that we got here is going to be our c value every time. So if you could memorize that, that's a lot more efficient. If you can know that the c value is going to be your y-intercept each time it's in standard form. So that would mean that our ordered pair would be 0, -7 for our y-intercept. On number 2, if we keep that same C value pattern in mind, C is 2. And so that means our ordered pair for our y-intercept is going to be 0, 2. So what that means when we're finding that, again, just as a reminder, is that we are looking for the point where it crosses the y-axis. So if I were to graph this equation right here, first of all, it's an a value that's negative, so I do know that it opens down, and then it has to cross 0, 2, that point on the y-axis. So 0, 2 would be right here. So the parabola goes through that point, and we know it opens down. So it could look so many different ways right now based on what we know. It could be over here. It could be over here. We don't know. We'll get into that more, how we figure out where it's located and in more details about it as we continue in this video. But the key thing in this section right here is that we know that the parabola crosses at the point 0, 2 on the graph, or on this one, 0, -7 on the graph down here. On number 3, we have -1 as our C value. So if -1 is our C value, then we know our ordered pair for our y-intercept is going to be 0, -1. So now we're going to determine the location of a parabola on the coordinate plane in reference to the y-axis. So we're going to look at an equation and know, will the vertex be over here on the left side, and either it opens up or open down, but to the left of the y-axis? Will it be to the right of the y-axis? So again, it could open up, it could open down, but the vertex being on the right side of the y-axis. Or is it going to end up on the y-axis and again, open up or open down, but actually have the vertex on the y-axis? So those are going to be our 3 positions: to the left of the y-axis, the right of the y-axis, or on the y-axis. And to figure that out, we look at the b value first, and then we also look at a. So it technically doesn't matter if you look at a then b or b then a, but you do have to look at both of those together and how they work together. So remember, that's our ax squared plus bx plus c. In that is our x squared coefficient and our x coefficient that we are going to look at. So for example, you can see in this table down here, I have some different scenarios. So I've got my positive a or my negative a, and then we have our positive b, negative b, or if b is 0. So I gave an example of each of these. There's essentially 6 types, because down here in this big box, there could actually be positive a or negative a, but it's going to do the same thing either way in terms of where the vertex is located. So looking at our first example, if we have a positive a value and a positive b value like this, so a is 1 and b is 4. Those are both positive. Doesn't matter what c is. We know c does tell us the y-intercept. So if I were looking at a problem altogether, I would know that this is positive a, so it's going to open up, and c is 3, so this would be 0, 3 is my y-intercept. So we're just kind of tacking on characteristics that we know about the graph as we go through this video. So now I can also determine if that graph is going to be over here on the left side or on the right side, or actually on the vertex, on the y-axis. So looking at this one, because our a value is positive and our b value is positive, the vertex is going to be located to the left of the y-axis. So again, that's because of the a and the b value. So left of the y-axis, which means it's somewhere over here. All right. And because the a value is positive, it is going to open up. So it's going to be somewhere over here. It could be up here. It could be down here. It could be here. It doesn't really matter, but it's to the left. The vertex is to the left. It could even be this, as long as the vertex is to the left of the y-axis. So it can cross over the y-axis, but the vertex itself is located to the left of the y-axis. Then we look at the same thing over here for the negative a. So if a is negative, I just took the same equation and changed it to negative a. So if the a is negative, but the b is still positive, then it is going to be located, the vertex will be located to the right of the y-axis. So here we have a is negative and b is positive. So then on the graph, the vertex is going to be located on the right side. And again, we do know because it's negative, it is going to open down. So we know that that graph is going to be something like this, or here, maybe here. Again, it could cross over, but the vertex itself will be to the right side of the y-axis. Now, when we have negative b values, it flips around in each of those scenarios. So if a is positive 1 and b is negative 4, so this time positive a, negative b, then instead of being on the left side like we see up here with positive and positive, we are going to see that this graph is going to be on the right side for the vertex. So the vertex will be on the right. It will open up because it's a positive a, so it will be opening up. So it could look like this, it could look like this, could be down here, and again, it could cross over, but the vertex will be to the right side of the y-axis. Then looking at our second column here of the two, we have the vertex is going to be on the left side of the y-axis on this one if our a is negative and our b is negative. So if they are both negative, then we are going to have on the left side, we will have the vertex. So again, if it's negative a, we already know that it opens down, but the b also being negative tells us it is going to fall on the left side for the vertex, but it could be up here, it could be down here, could be like this. It could cross over like we've been talking about, but the vertex has to be to the left of the y-axis. And then finally, we could have a b value of 0. And so there's a potential to have an a value that's positive or an a value that's negative. And so when we have a positive a value, remember that we know that that means it opens up. So we have this on this one. And then over here, if a is negative, it opens down. But further, if b is 0, meaning there is no b value there, no b term there, so that's going to be a 0. So if b is 0 on this one, and a is positive or negative, it's going to fall in the same spot. It's going to have a vertex that is located on the on the y-axis. So looking at our graph, if I were to sketch this, both of these examples are going to end up having a vertex on the y-axis. Now, on the left example over here, a equals positive 1, that's going to be something that opens up. So depending on the equation, it could look anything like any of these, as long as the vertex is on the y-axis. If it's like one of these where it's opening down, again, same concept. It could be anywhere on the y-axis, but it's going to be opening down, but the vertex will be somewhere on the y-axis. So that's what's known for sure if the b value is 0, no matter if it's positive or negative for a. If b is 0, the vertex is on the y-axis. So this would be a table that if you can memorize it, can help you out with some multiple choice problems that we will eventually look at and make sure that you're able to rule out some choices. So these last two characteristics take a little bit more calculating, so I am going to go through them, but ideally if you're able to determine if it opens up or down from A, where the y-intercept is from C, and whether the vertex falls to the left, to the right, or on the y-axis, those are going to be more beneficial in the sense of efficiency. These two, again, do take a few more calculations. So first, we're going to talk about how we determine the vertex. So we're going to find the vertex. To do that, we're going to start by calculating the x-coordinate by this formula that you would need to memorize. So the x-coordinate of the vertex is going to be found by doing negative b over 2a. And then once we have the x-coordinate, we plug in x to find y. So first things first, we're going to find a, b, and c. So looking at this, if a is 1, then b is 6, and c is negative 7. A couple things we already know about this graph, just as a note and a reminder of what we've already talked about. A is positive, so it does open up, okay? B is also positive, so if A and B are positive, then that means on the graph, your vertex is going to show up somewhere over here to the left of the y-axis, and then C is negative 7, and so that means our y-intercept on this is 0, -7. So the graph is going to cross down here at -7, and it's going to open up. So it's probably going to look something like this. With the vertex on the left side of the y-axis, it has to go through 0, -7, and it opens up. So those are some things that we know already, but let's say that that doesn't rule out enough multiple choice options on a multiple choice question where you're trying to match a graph to an equation. So if that's the case, then you might use this, find the actual location of the vertex to know. So x equals -b over 2a is what we're going to use. So -b is going to be taking the b value and putting a negative in front of it. So it was 6, now it's -6. If it had been -6, it would now be +6 because it would be -6. So -6 over 2 times 1, so 2 times a, and then from there we have -6 on top, and then 2 times 1 on bottom. -6 divided by 2 is going to be -3. So we know that the vertex is going to start with -3 as our x-coordinate. And then to find the y-coordinate, we're just going to plug in -3 into the x-coordinate here, here, those spots, into those x spots. So -3 squared plus 6 times -3 minus 7. And then we go ahead and evaluate. So following our order of operations, the first thing we can do is -3 squared. So -3 squared, -3 times -3 is 9. We can also do 6 times -3. 6 times -3 is -18, and we still have -7. 9 minus 18 is going to give us -9, and then -9 minus 7 gives us -16. So -16 is going to be our y-coordinate, and so that tells us that our ordered pair for our vertex is -3, -16. So looking at one more example, A is -4, B is 8, and C is 2. If you go through and rule out as many as you can, knowing A, B, and C and what that tells you about the graph, and you need to rule out some more, that's when you would use this. X equals -b over 2a. -b is going to be -8 over 2 times -4. -8 on top, 2 times -4 on bottom is also -8. Divide those. Negative divided by negative will be a positive. 8 divided by 8 is 1. So -8 divided by -8 is 1. And then we have our y. So to find y, we're going to plug 1 back into both of these x's. So that's going to be -4 times 1 squared plus 8 times 1 plus 2. So first thing we can do is evaluate our -4 times 1 squared. So starting with 1 squared, that's just going to be 1. So we have -4 times 1, which is just -4. Then we can do 8 times 1. 8 times 1 is 8, and then we still have plus 2. So -4 plus 8 is 4 plus 2. 4 plus 2 is 6. So our ordered pair is going to be this 1 and the 6 put together. 1 comma 6 is our vertex of this graph. So this last characteristic, again, is going to be hopefully something you don't have to use, but I do want to just point it out as an option in case you were to happen to come across a problem where you can't rule out enough using A, B, and C, and now even using the vertex that we just talked about. So to determine the x-intercepts of a quadratic function, we're going to plug in 0 for y, and then you're going to solve for x. Now, typically that's going to use either square root method or it's going to use factoring. But if it can't be factored or it can't use square root method, then you may have to use the quadratic formula. So that's why this one is really not the most efficient option, and ideally you wouldn't use this unless you absolutely had to. So looking down here, we have y equals 5x squared. And so we're going to start by, let's put ourselves in a scenario where we rule out options, but we still have 2 options left, and we already looked at our A, our B, our C, and our vertex, and that didn't help us out. So let's go ahead and take a look at those x-intercepts. So to find the x-intercepts, we're going to plug in 0 for y. So this is going to be 0 equals 5x squared. Now on this one, we are going to have square root method because there is no x with the x squared. It's just an x squared. So I can go ahead and get x squared by itself. So to do that, I'm going to divide both sides by 5. 0 divided by 5 is 0, equals x squared. Then we go ahead and square root both sides to get x squared isolated. So the square and the square root cancel each other out. 0 over here, technically we need a plus or minus in front, but remember that 0 doesn't have a positive and a negative, so it's just going to be x equals 0. So if our y we already know is 0, and we just found that our x is 0, this equation, this quadratic equation, has one x-intercept, and it's at 0, 0. And remember, we've talked about your parabolas could have 0 x-intercepts, they could have 1 x-intercept, or they could have 2 x-intercepts. So on this one specifically, there was just one. And this is, again, only used if you go through finding A, B, and C and the vertex, and all that doesn't rule out enough answer choices to get you the correct answer. All right, and then on number 2, similar concept, we put 0 in for y, and then we have equals x squared plus 6x minus 7. And so with this one, we won't be able to use square root method because there is an x squared and an x, but we will be able to try factoring. If factoring didn't work, then we would use the quadratic formula. So to factor, remember, you can go back and watch some of those videos on how you actually factor if you need a slower pace. But we've got x and x multiply back to x squared. Then we look at the factors of 7, which are just 1 and 7. So we put 1 here, 7 here. We check our inner and our outer product. 1 times x is 1x. X times 7 is 7x. We need those to combine to be this middle term, 6x. To get 6x from 1 and 7, we do 7 minus 1. So this is going to be a negative. This will be a positive. And then we can double check that negative 1 times 7 does get us back to negative 7, which is true. At that point, we take each factor, so x minus 1 is a factor, and then x plus 7 is a factor, and we set each of those equal to 0. So x minus 1 equals 0, and x plus 7 equals 0. At that point, we go ahead and solve each of those, so add 1 to both sides, we get x equals 1. Subtract 7 from both sides, and we get x equals negative 7. And then we have our ordered pairs. There are 2 here, so these don't go together. They're separate. They're each an x. So we have 1 comma 0 for y, because we know y is 0 for all x-intercepts, and then negative 7 comma 0 as our second one. So there are 2 x-intercepts here on this one. So in summary, we look at A to help us determine if the graph is going to open up or open down. If A is positive, then it opens up. If A is negative, it opens down. Remember, we look at A and B to determine if the parabola is going to fall on the left side, the right side, or actually on the y-axis. And that's referring to the vertex specifically. We look at the C value to determine the y-intercept, which is going to be always 0 comma C. Those are our top 3. Hopefully you would only need to use those 3 to actually determine what the correct answer is in a problem where we're given an equation, and then maybe you are trying to determine which of these graphs is correct, and you would rule out some of them based on what you know from these 3. Now, 4 and 5 are there as backups, but hopefully you would not need to use those. So finding the vertex, again, that's going to be finding x with negative b over 2a, and then y by plugging in that x. And then the absolute last resort is factoring and solving, or if needed, square root method and solving to find your x-intercepts.